Be smart about this. Hey y'all, this is Ishnai Laboratories. Welcome to my stream. Let me give a wander in because we're gonna start with this. Should probably. But yeah, I'm just gonna pull up the documents itself. We can see the what I'm reading. Woo! All right, y'all. For my European listeners, Germany had 90 minutes to prepare for a beach ball-sized meteorite impact. Earth is being pummeled by meteorites daily, but most of its residents aren't even aware. According to NASA's Planetary Defense System, Scout, nearly 50 tons of meteoric matter hit the planet daily. Most small pieces are never found, but occasionally a celestial fireball pushes through the atmosphere and lands in the ground. And on January 21st, outside of Berlin, this is this year, by the way, so January 21st, 2024, outside of Berlin, Germany, that's what happened. A meteorite on a wayward journey from the asteroid belt between Mars and Jupiter shattered into dozens of pieces, and meteorite hunters from around the world mobilized to begin their search. In San Francisco, meteorite astronomer Peter Jenkinson watched data from Scout as well as the European Space Agency's Meerkat asteroid guard system, which were tracking the meteorite from asteroid 2024 BX1. I'll just put colleagues, both professionally and hobbyists, fiercely began to work to predict where the object would land, teaming up with oh, I'm gonna slaughter this on every level. Lutz at the Museum für Naturkunde. He boarded his first 2 red-eye flights. I spent 9 hours layover in Newark, fruitfully calculating where I could expect the meteorites to have fallen. Once in Germany, they went down directly to the predicted strewn field south of the town of Rebec, partnering with more local organizers and hobbyists. Who had the local science community organized. After a search complicated by storms, this team began to recover. Was that actually a piece of it? Yeah, it was. Cool. On Thursday, February 1st. Yep, science stream. How are you doing, Banana? And that is a picture of it, well, a picture of it. But 90 minutes for them to get together to find where it was going to land. I am doing well. I'm excited about this. A landscape architect from Poland. I am going to slaughter all these names. Crispin I'm sorry, dude. I slaughter names on purpose. No, not on purpose, but I'm just Caspin or Crispin found the large piece about the size of a baseball. In meteorite world, he's known as the main mass holder. There's an entire community of fellow rock hounds. He plans to open a meteorite shop. Oh, I need to show this to what's his name? The follower. Oh, blah, 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 blah. 1 second. Will this accidentally pop? Yep. Okay. I'm gonna pull up. I'm gonna send this to somebody in our server who lives in Poland. Uh, Meteorite detection has improved over the last few decades, which is why teams were able to quickly locate the strewn field. Robert Lunsford, Fireball Director, come on. For both the American Meteor Society and the International Meteor Organizations. Say that is an absolute awesome director title. This particular meteorite was the size of a very large beach ball. When out in space, something this small is very faint. It was sheer luck that it was found prior to striking the atmosphere. NASA located the meteor and gave notification about 90 minutes before impact. That short warning is not concerning, says NASA's. Yeah, that is a D&D name. NASA's planetary defense officer, Lindley Johnson. If the object were large enough for some damage at the surface of the Earth could occur, it would have been spotted much earlier than just a few hours away. And the notification process is much more informal to ensure the best available information is provided to our governments and the public. Astronomers around the world report observations to the International Asteroid Warning Network. This is only the 8th time a small asteroid has been detected while still in space. One of the reasons it took several days after impact to find the meteorite fragments is that it's one of the rarest types of space rock, Auberite, which I want to show you what that is. Nope, you're not gonna. Okay, Auberite is installite pyrozenic rich. Oh god, we're gonna do this. Chondric. You know what? I'm just gonna wiki it. You know, Wiki's gonna be my friend on this. Nope. Group of meteorites named for Aubrey's, a small anadromite meteorite that fell. Composed of, okay, let's see what that means. Pyroxenes, group of rock formings, ignosilicate materials found in many igneous and metamorphic rocks. I was about to say, igneosilic, okay. When I wanted to become a a geologist. Silicate is basically silicone, if that's what you want to say. And they're usually formed in certain, like, let's say that. They usually have a same compound and how they line themselves up. And it's very, well, it's inorganic, as it says. But see, the structures themselves, double chained, these are what they're talking about. Let me show you. Because I have a lot of these, by the way, at home, because I am a nerd and have, used to, when I wanted to become a geologist, I collected a bunch of rocks. But also, it was a while back ago, so I can't quite remember all the ins and outs of it. But yeah, each one has their own kind of layout when it comes to those that they put in different classifications. Fire Stranger. Okay, it comes from... of course I figured the word pyro, but due to their presence in volcanic layers, lavas. Yeah, I mean, I guess. No, wonder why. White crystals of Fae. I have to remember Wait, but now I have to remember the okay, my mind's dying at the moment. Yeah, no, it's Fe for the periodic table. Iron, iron, ha! And Mg, I think, is magnesium. I am so tired right now. I know about that. You know, fuck it. Rich orthoponics, which includes nickel, installates, and minor phases of all-of-9 nickel iron metal. And tralolite, which indicates formation under extremely reducing conditions. Large angular broken fragments. I could understand that since they're meteorites for the most part. At least the one that we found, that was found. There's been suggestions that it may originate from the planet Mercury. Where did they say that one was coming from? It wasn't it Mars and general area? Alright, laters, hon. Right. 90% of meteorites are chondrites, which contain metal and are easier to find. Laborites look like Earth rocks. I could understand that. Oh, it means I can stay. Alright. To date, there's only fragments of of alborites in 11 collections worldwide. Some meteorites give us an idea of how long it took to build the Earth from small pieces. Others give us insight to the formation of the Earth's core. The type of meteorites give us a picture of what building blocks of the Earth might have looked like. Jenkins says that while most meteorites have a black or brown fusion crust, these alborite fragments have a clear crust like glass coating that allows the beauty of each rock to shine through. It's unique even among already rare alborites. He's not seen anything like it before and hopes to learn more about the origins of life and planetary defense and further study. Alright, on to the next one. The science first. Astronomers map waterite where planets are suspected to form. Fusion, huh? No clue. I haven't actually seen Steven Universe. An exciting discovery could shed some light on how the Earth got its water. New observations of a disk of dust and gas circling a baby star have revealed a large amount of water vapor at the exact location where baby planets might be starting to form. It's the first time that astronomers have been able to map the distribution of water in a planet-forming disk around a star that might be hospitable to life. Our recent images reveal a substantial quantity of water vapor at the range of distances from the star that include a gap where a planet could potentially be forming at present time, says astronomer Stefano at Stefani at the University of Milan. I never imagined that we could capture an image of oceans of water vapor at the same region where a planet is likely forming. One of the biggest mysteries of life on Earth is where the heck our planet's water came from. Some studies suggest that a lot of Earth's water was delivered by comets and asteroids. Others suggest that the Earth was born with its water, with no contribution from bombardment. Others suggest that it's a combination of those two mechanisms. We can't rewind time and look, but we can look at other planetary systems amid the throes of formation and see how they're doing. And this is where a young sun-like star called H.L. Tari, just 450 light years away from the solar system, is helping us out. The stars are born in... I mean, it can still be lava. It's just the water would be in mist form. Or vapor. Stars are born in lavas. I mean, water vapor, ice, all this other stuff. A super dense... stars are born in disk clouds of dust and gas. A super dense knot in this material collapses under gravity and starts spinning. As it spins, the material around it, emerging central star, arranged into a disk that circles growing star, feeding mass into it. Imagine water swirling around a drain. Once a star is formed, any material that didn't feed on start starts clumping together to form other stuff in a planetary system. And planetary system, all the planets and moons and asteroids and comets. That's where H.L. Tari is now. It's less than 1 million years old and surrounded by a broad, cool, stable disk. If you look at from observations from the large millimeter submillimeter array, ALMA, you'll see that the disk has a centric gaps. I think that's the image. Yeah. Centric gaps. The astronomers believe that those gaps are carved out by planets forming. I'm guessing that right there. Sweeping up material in the disk that they orbit the star, as they orbit the star. Because it's so close, angled in such a way that we have a clear view of the disk, and the star H.L. Tari is similar to a young sun. And the water has been detected in the disk before. The scientists wanted to take a closer look and figure out what precisely the water is, which is a clue to where it will end up eventually. They took new observations of the star with ALMA, using 2 different wavelength bands to target water vapor. They found a significant amount of water in the inner region of the disk, within 17 astronomical units of the star, where terrestrial planets like Earth are expected to form. That region contains at least 3.7 times as much water as found in all of Earth's oceans. Even more strikingly, the water was found in a known and prominent gap in the disk, which means that there's a very good chance that water is being incorporated into any planets that may be forming there. A recent study found that the water was abundant in the solar system before Earth formed. This first map of spatial distribution of water in a protoplanetary disk shows the Earth could very well have been born with at least a large proportion of its water, even if some was later delivered by asteroid bombardment. Our results show that how the presence of water may influence the development of a planetary system, just like it did some 4.5 billion years ago in our own system. I have them hopefully set up so that we're doing all India, well, we have something about India space, but I have everything for space lined up, and then we go on to biology, and then we go on to the new stuff about autism. Well, not new, it's just I found out about it new. The metal scar of a devoured planet reveals a zombie star's cannibalistic past. Love this name. The dastardly deeds of I love Science Alert. I love their articles and how they're written. The dastardly deeds of a dead star have been discovered by an intrepid team of cosmic detectives. A white dwarf star that devoured at least a chunk of one of its planets has been betrayed by a scar of vaporized metal marring its surface. The telltale remains of a planet that once orbited the star before spiraling to its doom. What makes it even more interesting is that rather than spreading out across the surface of the star, the material was localized to one place. Its discovery helps necroplanetologists understand exactly how these stellar remnants swallowed the planets that once sailed around them in serene orbits. It is well known that some white dwarfs, slowly cooling embers of stars like our sun, are cannibalizing pieces of their planetary systems, says astronomer Stefano Bagnolo of the Armagh Observatory and Planetarium. Now we have discovered that the star's magnetic field plays a key role in the process, resulting in a scar on the white dwarf's surface. White dwarfs are what remain when a star like the sun has ended its main sequence of lifespan. As they run out of material to fuse in their cores, these stars puff out and out into enormous red giants before finally ejecting their outer material. The core, no longer supported by fusion, collapses under gravity, forming a dense object up to 1.4 suns in mass, packed into a sphere around the size of the Earth. These death throes are extremely energetic, and their remnant core is extremely hot, and will continue to shine with residual heat for what could be trillions of years. That's a white dwarf star. Shockingly, planets have been found to continually to orbit white dwarf stars, suggesting they'll be able to survive this process. On the other hand, planetary material has been found in the atmospheres of white dwarfs, indicating that not surviving planets live happily ever after. These stars are known as polluted white dwarfs, and they are another way to study planets that have survived the death process of the precursor star. That's because a planet's heavier elements should sink towards the core of a white dwarf pretty quickly. A polluted white dwarf is one that has snacked recently. But a polluted white dwarf named WD0816-310 is unlikely any other that we have seen. Previous observations have revealed the presence of sodium, magnesium, calcium, chromium, manganese, iron, and nickel. The scientists wanted to confirm and analyze these detections and figure out what they could tell us about the object eaten by the star. They took new observations and quantified the strength of the stellar spectra that signified the presence of metallic elements. And what they could infer about the object was amazingly precise. We have demonstrated that these metals originated from a planetary fragment as large or as possibly larger than Vesta. It's about 500 kilometers, or 310 miles across, and the second largest asteroid. Says in the solar system, says astronomer Jay Farhi of the University College London. But the teams picked up some new in their observations. The strength of the elemental signal changed as the star rotated. This strongly suggests that rather than spreading out evenly throughout the star's atmosphere, the vaporized metals remained confined in one location. But researchers also found as a clue of how this happened. The changes in the signal's strength were synchronized to changes in the strength of the star's magnetic field, implying a correlation between the structure of the white dwarf's magnetic field and the local surface density of metallic elements. Surprisingly, the material was not evenly mixed over the surface of the star, as predicted by theory. Instead, this scar is a concentrated patch of planetary material held in place by the same magnetic field that has guided the infalling fragments, says astronomer John Landstreet of Western University of Canada. Nothing like this has ever been seen before. This discovery suggests as a planetary material falls into the white dwarf, it is funneled in by the magnetic field, which keeps the material in place. The reason why we've never seen this before, the research posited, is generally only a snapshot of a white dwarf spectrum ever obtained. Taking multiple observations over the years revealed a variability that can't be detected on just a single observation. Perhaps if we revisit some other polluted white dwarfs detected over the years, we might find a few more surprises. Space accident means grades may have might have contaminated the moon. Yay. You know, the little ones, you know, the small little cute ones that have survived, you know, re-entry into the Earth. Just over 5 years, February 22nd, 2019, an unnamed space probe was placed on orbit around the moon. Name the Beresheet, and built by Space IL and the Israeli aerospace industries. It was intended to be the first private spacecraft to perform a soft landing. I wonder why the United States is suddenly interested again. Among the payloads, probe's payloads were tardigrades, renowned for their ability to survive even the harshest of climates. It survived coming back down. It was in the Challenger spacecraft. Yeah. The mission ran into trouble from the start with, or was it Challenger or was it Columbia? Ran into trouble from the start with the failure of star tracker cameras intended to determine the spacecraft's orientation and thus properly control its motors. Budgetary limitations had imposed a pared-down design. While the command center was able to work around some of the problems, things got even trickier on 11th of April, the day of the landing. General statement. We seem to be sucking on the landing because we're going to get to it, but this year's had problems too. On the way to the moon, the spacecraft had been traveling at high speeds. It needed to slow way down to make a soft landing. Unfortunately, during the braking maneuver, a gyroscope failed, blocking the primary engine. At an altitude of 150 meters, the Beresheet was still moving at 500 kilometers per hour, far too fast to be stopped in time. But definitely very violent, goodness. The impact was violent. The probe shattered and its remains were scattered. Why was it trying to put those on there then? Why did you have to partner the payloads if you were just the first time? This probe shattering the remains scattered over a distance around the hundreds of meters. We know this because the site was photographed by NASA's LRO Lunar Reconnaissance Orbiter satellite, 22nd of April. Animals can withstand almost anything. So what happens to the animals that were traveling on the probe? Given their remarkable abilities to survive situations that would kill pretty much any other animals, could they have contaminated the moon? Worse, might they be able to reproduce and colonize it? Tardigrades are microscopic animals that are measured less than a millimeter in length. All have neurons, a mouth opening at the end of a retractable proboscis, an intestine containing microbiota, and 4 pairs of non-articulated legs ending with claws. And most have two eyes. As small as they are, they share common ancestors with arthropods such as insects and arachnids. Most live in aquatic environments, but they can be found in any environment, including urban ones. Emmanuel Dadagali, a researcher at the CERN's CNRS, collects them in mosses and lichens of the Jardin des Plantes in Paris. To be active, feed on microalgae such as chloria, and move and grow and reproduce. Tardigrades need to be surrounded by a film of water. They reproduce sexually or asexually via parthenogenesis from an unfertilized egg, or even hermaphroditism, when an individual possessing both male and female gametes self-fertilizes. I think the animals in Subnautica, at least for the first planet, did that. The new one's supposed to be in a different planet. What's the Once the egg is hatched, the active life of a tardigrade lasts from 3 to 30 months. A total of 1,265 species have been described, including 2 fossils. Tardigrades are famous for their resistance to conditions that exist neither on Earth nor on the Moon. They can shut down their metabolism by losing up to 95% of their body water. Some species synthesize a sugar trihaloose that acts as an antifreeze, while others synthesize proteins that are thought to incorporate cellular constituents to an amorphous glassy network that offers resistance and protein and protection to each cell. During dehydration, tardigrade's body can shrink to half its normal size. The legs disappear with only the claws still visible. This state, known as cryptobiosis, persists until conditions for active life begin favorable again. Depending on the species, individuals need more or less time to dehydrate, and not all species of the same species can maintain and return to active light. Dehydrated adults can survive for a few minutes at temperatures as low as negative 272 Celsius or as high as 150 Celsius, and over a long term at high doses of gamma rays of 1,000 to 4,400 gray. By way of comparison, a dose of 10 Gs or grays is fatal for humans, and 40 to 50,000 Gs sterilizes all type of material. However, when the dose radiation kills whatever the dose, radiation kills tardigrade eggs. What's more, the protection afforded to the cryptobiosis is not always clear-cut, as the case of the Melanesium tardigradium, where radiation affects both active and dehydrated animals in the same way. Lunar life. So what happened to the tardigrades after they crashed on the moon? Because why were they thinking of doing that again? Are any of them still viable, but buried under the Earth's, the moon's regoth, the dust that varies in depth from a few meters to several more dozen meters? First of all, they'd have to survive impact. Laboratory tests have shown that the frozen specimens of the Hibiscus dargeni species traveling at 3,000 kilometers an hour in a vacuum were fatally damaged when they smashed into the sand. However, they survived impacts of 2,600 kilometers an hour or less. And the hard landing on the moon, unwanted or not, was far slower. Oh god. The moon's surface is not protected from solar particles and cosmic rays, particularly gamma rays. But here too, tardigrades would be able to resist. In fact, Robert Wyman Grober, professor of the University of Klein in Germany, and his team showed that doses of gamma rays hitting the lunar surface were permanent but low compared to the doses mentioned above. 10 years of exposure in the lunar gamma rays would correspond to a total of around 1 gamma ray or guy. But then there's the question of life on the moon. Tardigrades would have to withstand a lack of water, even though there is water on the moon, except it's ice, as well as temperatures ranging from negative 170 to negative 190 Celsius during lunar night, and the 100 to 120 Celsius during the day. A lunar day or night lasts a long time, just under 15 Earth days. The probe itself wasn't designed to withstand such extremes, and even if it hadn't crashed, it would have ceased all activities just after a few Earth days. Unfortunately for the tardigrades, they can't overcome the lack of water, oxygen, and microalgae. They would never be able to reactivate, much less reproduce. The colonization of the moon is thus impossible. Still, inactive specimens are on the lunar soil, and their presence raises ethical questions. I mean, yes, it does. As use silk ecologists at the... Why were they bringing it in the first place if they knew they couldn't bring them back? Why were they in the payload? Points out. Moreover, at a time when space exploration is taking off in all directions, contaminating other planets could mean we'd lose the opportunity to detect extraterrestrial... Yes, but also, why was it in the payload in the first place? Like I said, it wasn't like we were going to get it back, and they already knew that it was only going to last like a few days. Just... okay. Speaking of lasting only a few days... Merely 1 week after tumbling into the lunar surface and its historical journey, the moon lander Odysseus has officially ended its brief mission, at least for now. Speaking of, what difference does this, since it is also a private organization, from the other one, which also was a private organization? Why do we call this one historic, but the other one not? Of course, because it was a probe and not a lander. Mission Control has shut down the lander in preparation for the long lunar night, which is about, what it said, 14, 15 days on Earth, but not before receiving a final image of a cratered landscape and the dark sky featuring a tiny crescent Earth in the blinding glare of the sun. Right there. Yeah. I don't care. I don't care. Course power depleted. Odysseus completed a fitting farewell transmission. Received today, this image from February 22nd showcases the crescent Earth in the backdrop. A subtle reminder of humanity's presence in the universe. Good night, Odie. We hope to hear you again. Half a century has passed since the last Apollo missions left lunar surface, making the Odysseus mission a historic return for the U.S. Okay, so it's for the U.S. It's nothing else. Of course, the only reason why we're paying attention, of course, is because everybody else is doing it now. The Houston-based planet company Intuitive Machines was endorsed and utilized by NASA as part of its commercial lunar payload services program to carry technology that would collect critical information to assist in the transporting astronauts to the moon. It's been hoped to make use of commercial ventures could allow NASA to focus its time and resources on the scientific side of space exploration. No, it is not. Coming from somebody who worked at a Space and Rocket Center, which isn't a museum. It is a museum. No, from what I heard from the NASA scientists, well, retired NASA scientists there, the whole thing of focusing its time and resources in the scientific side of things is no, because lobbyists came around and said, oh, the commercial people can do it cheaper and better, and no, they don't. In fact, one of the jokes that all the scientists had around the museum, because they were docents at the time, was they could get stuff done and fixed while the private contractors and that were a part of the commercial businesses that were working with would stand there for hours waiting for, get permission to do this other stuff, and the ones that were working for NASA went around and got it done in half the time. Sometimes for half the budget. They had to be creative about it. Flight controllers made use of a separate experimental navigational... A rapid descent and single neglected locking mechanism came close to ending the mission in complete obliteration as the affectionately nicknamed Odie approached the moon at a speed without its range-finding lasers operational. Flight controls made use of a separate experimental navigational system being carried on board to guide the craft to its target site close to the moon's south pole. Though the lander avoided a devastating crash landing, its touchdown was far from perfect. It was an unfortunately positioned obstacle catching one of Odysseus's 6 legs in the final seconds, sending the telephone booth-sized vehicle toppling on its sides. Oh no, the TARDIS! What did we do? With its solar panels in shadow and night creeping over the landing site, it's unlikely the lander will find energy to reawaken when the lunar dawn breaks in the several weeks. Though Intuitive Machines CEO and co-founder Steve Athelmus isn't quite ready to give up on the mission yet. I don't think what we're going to do is... I think what we're going to do is kind of tuck Odie in for a cold night of the moon and see if we can't wake him up when he get a solar noon here in about 3 weeks. Such an awakening isn't without recent precedent, as Japan's Slim spacecraft sparked back to life last week after a similarly awkward landing. While Odie might not be completed its bucket list, it still managed to transmit a few images of its surroundings. With its last parting shot featuring a distant Earth twinkling in the background, it's hard not to feel some kind of empathy for not just the lander, but the team who worked so hard to send it here. There. There's something since we're speaking about... Yeah, there we go. India unveils astronauts for first human spaceflight mission in 2025. India has revealed a short list of Air Force pilots who will fly the country's first human spacecraft mission. I'm gonna slaughter all these names. I am so sorry ahead of time. Indian Prime Minister Narendra Modi unveiled 4 astronaut designates at the Vikram Sarabhi Space Center, the southwest of the state of Kerala, on Tuesday, February 27th. The selected individuals are Group Captain... I repeat, I am so sorry. I will say this again, I am so sorry. Prasantha Balakrishna Nair, Group Captain Ajit Krishna, Group Captain Angat Pratap, and Wing Commander Nishu Shukla. All 4 are test pilots. Modi called them the pride of today's India. The quartet have been undergoing training at the Indian Space Research Organization's astronaut training facility at Bengaluru. The 3 men who will form the first Naganya mission is expected in 2025. This will see the crewed spacecraft spend 3 days in orbit at 249 miles or 400 kilometers above Earth. Ganga, is the Sanskrit word for celestial vehicle. The announcement follows the ISRO's making progress on an engine for the rocket that will launch the Gangayaan. The agency has been performing a number of major tests, including verifying an emergency escape procedure and recovery procedures as it gears up a full-blown mission. India plans to launch its first uncrewed test before the end of the year as a step towards sending humans into orbit. At present, only the United States, Russia, and China have the ability to independently launch people into space. Indian space program has scored a number of successes in the last year. Achievements include the landing on the moon with a robotic Chandrayaan. If I remember correctly, the Chandra actually means is goddess or in the moon or something. Mission and launching Idea-1 solar probe to Earth-Sun Lagrange point 1. The only reason why I know how to say Lagrange correctly is because I might have watched Gundam Wing. The country boosts these milestones, set out a plan to establish orbiting space station by 2035 and putting astronauts on the moon by 2040. Yeah, we'll no longer have an international space station. We'll just have each nation, once again, having their own. Alright. Scientists discovered the most epic pair of supermassive black holes ever seen. Most epic pair. Okay. Sorry, I love science alerts sometimes. A galaxy is some 750 light years away has been discovered, hosting a heaviest pair of supermassive black holes we've ever seen. The pair have combined mass of a whopping 28 billion times the mass of the sun. While there are certainly individual black holes that exceed that mass, the pair, lurking in a galaxy called B20402 plus 379, represent the chunkiest black holes binary we've ever found. Chunkiest. Yeah, Ilya, it really is. Um, but hey, when I used to work at the Space and Rocket Center, they said we'd have people back already on the moon at this time of period. So, about Rooster Teeth? No, what happened? Is he dead? Did Toyama die? Oh, he's only 68. That's sad. Goodness gracious, that was sudden. Didn't even know he was sick with anything, but probably knowing how the industry is, they probably kept it from fans and all this other stuff. Damn. But yeah, no, when I was in middle school, they kept on saying that ours was the generation that would be back on the moon. And then when I was working at the Space Center, it said the next generation will be the ones will be on Mars. I'm like sitting here going, yeah, no. The only reason why we went to the moon is A, to say suck it, Russia, and B, because that was John F. Kennedy's wish, and since he got assassinated, the people were kind of guilt tripped into it, kind of thing. Because the scientists in NASA were more than willing to want to continue going on. They just had a bunch of their funding cut. To the point where they lost the plans on how to make the Saturn V rocket. I kid you not. We don't know how to make the Saturn V rocket. We don't know how to get back to the moon. In that sense, because we lost the Saturn V rocket plans because of the downsizing so quick. '68. Acute subdural headache. What did the fuck is that? True. Well, I mean, the reusability of space shuttles is one thing. It's just it was not designed um for going back to anything else. It was just for reuse for the International Space Station more than anything else. Subarachnoid hemato, a serious condition where the blood collects between the skull and the surface of the brain. Ouch! What he died from that? Ow! Pure after head injury? Huh? Did he fall? Yeah, but that was kind of their excuse when it came down to it because if I remember correctly, what the scientists were saying while I was working there was um, they were really going after NASA for the price tag of everything. They're really pricing them on stuff. And that's what they tried to sell it as to try and. Because it just became. The scientists that I remember talking to just talked about how as soon as they were to the moon, the government was done with doing it. It was, like I said, one of those, fuck you, Russia, we made it here first. And everybody lost, no interest in it anymore. Cut the funding quickly. Or a slow death with some of the locations. That's the reason why we're now doing commercial. Massive hole was what's left. The Kustler of. Right. We're talking about chunky. I mean, the only reason why we got interested in the first place was because Sputnik. And then the American people were like, oh no, we have a satellite spinning around us. Oh no. Oh no. They could be spying on us with that kind of technology. No, not really. But fear does things to people. Kind of like, you know, signing over their basic rights. That too, yeah, but at the time they could have. Well, people didn't know how nukes really worked back then, anyways, so I guess I could understand them, you know, tying the two together, but. Back to the chunkiest black hole binary we've ever seen. And they exhibit several particular properties that are helping astronomers figure out what happens to this gargantua when they come together. Gargantua, when they come together. The growth of black holes into a supermassive size is a mysterious process whose vagaries are largely unknown for certain. Small black holes form from the collapse. You know, just the thought that occurred to me with nukes is, yeah, they tried to, you know, soothe the public by saying, you'll survive if you hide underneath your, you know, table at school. That's how you will survive. When the nuclear warnings go off, just hide underneath your desk. You'll be safe. Anyways, small black holes form from the collapsed cores of massive stars that have burned through their atomic fuel and can no longer shine. It's true, but I mean, if they're going for a school, if where schoolhouses usually are located are within the city rather than outside the city, and if the person's targeting the city, I think that the school is gonna go. But yeah, it was still more of a calm them down method than it was. Have you seen those cartoons where it makes it sound basically like you'll survive? You'll be fine. You won't die later of, you know, radiation poisoning or anything. Oh, I do have something about Chernobyl, by the way, when we're speaking about, but let's finish this, the science things, because I have it set up so it's kind of in a, where we're doing space, and then we're going there, but there's a update about Chernobyl that will be interesting later on. Oh, you haven't seen the cartoons? Okay, 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 1 second. Atomic alert, but is atomic alert what you're talking about? Let me see. Fine, there's a little small part of atomic alert. Oh, hiding. I think it's atomic alert. Hiding. Yep, no, that's not the animation I'm looking for. uh, okay. I shouldn't spend time looking for this. I'll go back to this. ADHD? Me? Never. Small black holes form from the collapsed cores of massive stars that have burned through their atomic fuel and can no longer shine. These stellar mass black holes can grow by colliding with each other to produce objects too massive to form via the core collapse pathway. There has to be some method whereby black holes can grow into supermassive proportions, millions to billions of times the mass of the sun. It seems reasonable to assume that if small black holes can collapse and merge, big ones should be able to do as well. A series of hierarchical mergers eventually produce the giant black hole that sits at the heart of every galaxy. But there's a potential problem, according to the theory. Black holes and binaries grow close together by shedding their orbital momentum, transferring it onto nearby gas stars that shoot off into parts unknown, and losing it in the form of gravitational waves. As the orbital distance shrinks, so does the region of space to which they can shed their energy. At a distance of around a parsec, or 3.2 light years, there is no longer enough room to shed further momentum, so the orbital decay stalls and stabilizes. This is known as the final parsec problem. B20402 plus 379 might, according to a team led by astrophysicist Tirth Suri of the Stanford University, Surti of the Stanford University, be an excellent example of the final parsec problem in action. Researchers made a careful study of the archival data collected by the Gemini Multi-Object Spectrograph on the Gemini North Telescope and made a new analysis that calculates the properties and behavior of the two black holes embedded in the center. The result gave us the mass of the binary, 28 billion solar masses, and find that the galaxy itself is a fossil of a cluster of galaxies. B20402 plus 379 was once a group of galaxies hanging out, but eventually they smooshed together and became B2, well, what we have today. The binary supermassive black hole is what is left of the cluster of black holes that fell into the the galactic center and remained there. Those two black holes are separated by a distance of 7.3 parsecs, or 24 light years. That's not quite the final parsec, nor is the tightest supermassive black hole binary we've seen. But what makes it interesting is that the team's analysis indicate that the orbital decay has stalled. Those black holes have been separated by that distance in stable orbit for some 3 million years. The discovery indicates that the high mass might have a role to play in the final parsec problem. The team thinks that at the previous orbital decay of the binary ejected so many stars from their vicinity that there are simply now none left into which they can transfer their orbital momentum. They're pretty well stuck for now. Normally, it seems that galaxies with lighter black hole pairs have enough stars and mass to drive the two together quickly, says astrophysicist Roger Ramani of Stanford University. Since this pair is so heavy, it requires a lot of stars and gas to get the job done. But the binary has scoured the center of the galaxy of such matter, leaving it stalled and accessible for our study. So what happens now? We know that somehow black holes can grow larger than the binary's combined mass, but these ultramassive behemoths seem to be pretty rare. The nuclear binary of the galaxy seems to be highly stable, with no immediate means of shedding orbital momentum. It could gain a kick in the right direction from the ejection of material that would follow another galactic merger, sending a third massive black hole into the party. But all the galaxies made up in the initial cluster have already merged into the form, so that doesn't seem to be on the cards. There is, however, another possibility. There might be some material within the galaxy that could give the stalled union a helping hand. We're looking forward to follow-up investigations of the core, where we look to see how much gas is present. This should give us more insight on whether the supermassive black holes can eventually merge, or if they will stay stranded as a binary. Perfectly synchronized planetary system probe for signs of alien technology. Some 100 light years from the solar system dwells the most mathematically perfect planetary system we've ever seen. The star at its center, a temperate orange dwarf called HD 110067, is orbited by 6 exoplanets, each of which travels in harmony with its adjacent worlds. Such a perfect chain of orbital resonances is extremely rare, and it means that the system has remained relatively stable and undisturbed since it's formed around 1 billion years ago. This is interesting in its own right, and scientists are studying it accordingly, but it has another implication. Such steady stability, according to the team led by astrophysicist Carmen Chaza of the SETI Institute, offers a good opportunity for life to emerge, evolve, and grow and thrive. See, these are I guess it's talking about the pattern? An illustration showing the resonance change of the exoplanets. That's kind of cool to look at. Sure. He and her colleagues have conducted a thorough search for radio signals that provide evidence for past or present technology, such as technosignatures. While they turned up previously zilch, they believe the system is intriguing enough to be worth revisiting in future with more sensitive observations. Finding alien technosignatures in the Milky Way is a difficult prospect. The galaxy is very large, and we don't even know what we're looking for. If we take Earth as a template, the only world on which life is known for certainty, and by extension, the only world which technology is known to emerge, our radio signals have only propagated for a distance of around 100 light years. What's more, those far-off waves would be incredibly faint to boot. But we can take the type of radio emission produced by Earth technology and extrapolate it from which some alien technology might look like to generate a wavelength range and pattern for signals to look for. That's what scientists at SETI have done, and they use this to scan nearby systems to see if they can detect any signals that will match. The HD 110067 system is a tantalizing one. Not only is it remarkably stable, all 6 worlds are smaller than Neptune, and some of them could conceivably have liquid water on the surface, which is one of the checkboxes scientists use for search of life. To look for alien technology, Chalza and her colleagues combined combed through archival data from the Green Bank telescope in search of the telltale stretching and scrunching of key frequencies as the hypothetical civilization looped back and forth around in the orbit around its stars. After eliminating any signals that might originate from Earth, researchers came up with no sign of alien technology from that particular search strategy, which is kind of bummer in one sense, but it's only ruling out one of the possibilities of what could be many. When it comes to aliens, we don't even know what we don't know. What we do know is all the physical characteristics of this system remain just as tantalizing as they were before the researchers ruled out technosignatures of a specific nature. While we find no signals within the search, we anticipate returning to the system and others like it in the future with increasingly sensitive and diverse search methods, said Chalza and her team in their paper. This unusual system remains an interesting target for future technosignature searches. Okay. We're gonna take this with a grain of salt because I remember them saying we finally kind of having this answer before, so we're gonna take this next one with a grain of salt also. We finally know what brought light into the dark. To the dark and the formless void of the early universe. Yeah, I know, right? According to the data from the Hubble and James Webb Space Telescopes, the origins of free-flying photons in the early cosmic dawn were small dwarf galaxies that flared to life, clearing the fog of murky hydrogen that filled the intergalactic space. This discovery unveils the crucial role played by ultra-faint galaxies in the early universe's evolution. Says hydrophysicist Ira Kamirska of the Institute of Astrophysics in Paris. They produced ionized photons that transformed neutral hydrogen into ionized plasma during cosmic reionization. It highlights the importance of understanding low-mass galaxies and shaping the universe's history. At the beginning of the universe, within minutes of the Big Bang, space was filled with a hot, dense fog of ionized plasma. What little light there was wouldn't have penetrated this fog, and photons would simply have scattered off the free electrons floating around, effectively making the universe dark. As the universe cooled after about 300,000 years, protons and electrons began to come together to form a neutral hydrogen and a little bit of helium gas. Most of the wavelengths of light could penetrate this neutral medium, but there was very little in the way of light sources to produce it. But from this hydrogen and helium, the first stars were born. Those first stars delivered the radiation that was strong enough to peel electrons away from their nuclei and reionize the gas. By this point, however, the universe had expanded so much that the gas was diffused and could not prevent light from shining out. By about 1 billion years after the Big Bang, the end of the period known as the Cosmic Dawn, the universe was entirely reionized. Ta-da! The lights were on. But because there's so much murk in the cosmic dawn, and because it's so dim and far away across time and space, we've had trouble seeing what was there. Scientists have thought the sources responsible for most of the clearing must have been powerful, huge black holes, whose having moments, accreting produces blazing light, for example, and large galaxies in the throes of stars formations, baby stars that produce a lot of UV light. The James Webb Telescope was designed, in part, to peer into the cosmic dawn and try and see what lurks within. It's been very successful, revealing all sorts of surprises about this crucial time in the formation of our universe. Surprisingly, the telescope's observations now suggest that dwarf galaxies are the key player in reionization. An international team led by a hydrophysicist Akim Atek of the Institute of Astrophysique de Paris turned to, I'm guessing I'm saying that right, the James Webb Telescope data on the galaxy cluster called Able 2744, backed up with data from Hubble. Able 2744, is so dense that the space-time warps around it, forming a cosmic lens. Any light distance traveling to us through that space-time becomes magnified. This allows the researchers to see tiny dwarf galaxies close to the cosmic dawn. Then they use the telescope to obtain detailed spectra of these tiny galaxies. Their analysis reveals that not only are these dwarf galaxies the most abundant type of galaxy in the early universe, they are far brighter than expected. In fact, the team's research shows that the dwarf galaxies outnumber the large galaxies by 100 to 1, and their collective output is 4 times the ionizing radiation usually assumed for larger galaxies. These cosmic powerhouses collectively emit more than enough energy to get the job done, Atek says. Despite their tiny size, these low-mass galaxies are prolific producers of energetic radiation, and their abundance during this period is so substantial that their collective influence can transform the entire state of the universe. It's the best evidence yet for the force behind reionization, but there's more work to be done. The researchers looked at one patch of the sky. They need to make sure their sample isn't just an anomalous cluster of dwarf galaxies, but is a representative sample of the entire population of the cosmic dawn. They intend to study more cosmic lenses regions of the sky to obtain a wider sample of early galactic populations. But just on this one sample, results are incredibly exciting. Scientists have been chasing answers on reionization for as long as we've known about it. We're on the brink of finally blowing away the fog. We have now entered uncharted territory with the James Webb Telescope, says astrophysicist. I'm so sorry, I'm slaughtering all these names. Mia Nayakura of Swinburne University of Technology in Australia. This work opens a more exciting questions we need to answer on our efforts to chart the evolutionary history of our beginnings. But no, I found this really interesting. And yeah, I'm sorry I slaughter names. One of the other reasons why I pull up the whole article itself is because also to show the examples that the article itself shows so we can see these images, but also to show their names to know, I suck at saying names, but I mean, here's the name of the person if you want to search it up, and I'm so sorry.